reaction, what we're going to do now, this is the sacrifice of the gummy bear. I have a chemical that we're going to add to it. We have potassium chlorate right here. This is a common ingredient in many fireworks. It is an oxidizer. It's very flammable. It's very explosive. They also use this in exploding targets, if any of you guys have ever played around with those things. Like I said, this is an oxidizer. We're going to put about 4 grams of it in there. It's about almost a half a teaspoon. And this type of measurement is what I use for this reaction. Then I'm going to take the torch and we're going to get this really hot. We're going to melt this down to where it's liquefied. And the melting point of this is pretty low, so it melts fairly quickly for us. We're just going to get it super hot. The reason is it's a lot like, think about Indiana Jones and the Temple of Doom. We're going to have a pot of boiling nastiness that we're going to toss this little innocent gummy worm into here in just a moment. We're going to melt it down to where it gets good and molten and bubbling. If you see any sparks or anything, that's leftover remnants from a last experiment. Nothing is happening yet, it's just getting hot. You can see the steam starting to come out of it, meaning that we have some signature evidence that boiling is starting to occur. So once we get it to where I got all my stuff molten, it's been hot, we're ready to roll. We're going to take a gummy worm. I'm going to be even meaner to him and cut him in half because it works better. Toss him in. Oh! World gummy bear! You can see him kind of wriggling and writhing and dying down in there. And his remnants are caked onto the bottom of my test tube now. Now this reaction,
What if you use the real word?
let's look at the evidence of chemical reactions that we had here. This one here is awesome for that because number one, what was the first thing you guys noticed when I tossed that gummy worm in?
It started like
It was like a firework.
It was like a firework. It became purple. It was bright. It was a lot of light was being produced. Now, what else are we producing?
Gas.
Lots of smoke, lots of gas going on here. Did it change colors?
Yes.
Yeah, we got a lot of different colors going on here. We've got really dark black down in here in the bottom.
That's awesome.
We got some white stuff caked up here towards the top on the sides. We got color change so far. You guys said that it had light. We got it. It's really hot. You could feel the heat coming off of this. So we got a heat being produced. Did you hear it? It's like
It's not a firework.
There's heat,
Was
bubbles.
there bubbles too? It had bubbles. It had it all.
So what would
Now,
you put in the first one?
What we have going, or whatever you observe happening here, it could be a variety of things. Green fire demonstration. What we have going on here is I have boric acid. That's this stuff right here. It's H3BO3. What we're gonna add it to one of the Petri dishes. We're just gonna sprinkle it in the bottom of the Petri dish. Not a whole lot, just enough to kind of coat the bottom of it. It doesn't take much for this to work. And then we're going to use methyl alcohol. Now, rather than go with the scientific version of getting lab-grade methyl alcohol, I simply just use heat, which is a gasoline antifreeze that you buy at an automotive store. And you put it in, let it soak up the boric acid. I'm going to put some in this Petri dish that doesn't have anything in it so that we can see a comparison here. If you guys want to grab light so that it makes it a little bit easier to view, as we're ready now, we will ignite it
You
so
may
that
start this.
we can see what's going on.
Oh.
That's the green fire. There's your plain fire.
That's awesome.
You can see the one with the boric acid, please step back. The one with the boric acid in it does have a bright green flame. That's some of those chemical properties of elements in the periodic table. When they burn, they put off different colors. That's especially important in fireworks production and manufacturing because many people that manufacture and create fireworks worry about what colors they're going to produce when they do explode in the air. Strontium makes red. Boron, like this, makes a green color. Sodium in a firework makes a yellowish color. The list goes on and on and on. And so as it burns out, you can see as the boric acid burns up, it turns to just a normal bluish red flame. Alright, for the burning bubbles, we're simply going to take the butane. I'm going to put it into the bubbles inside of my beaker here full of soapy water.
Whoa.
Sometimes it gets a little out of control. Once we get a nice pile of butane bubbles there, I'm going to scoop up some of them. Take our lighter. We're going to ignite them.
Whoa.
I felt that